Hey everyone, this is Sunny again. Let me welcome you to the iNeuron channel again. So today we are going to talk about a very interesting topic, that is what is a rule-based system and what is an AI-based system, or like say machine learning-based system, and how they are going to be very different. So we will see it actually with a practical example, okay? Because if you are one of those people who love practicals, who like to do an experiment and just to verify whatever knowledge you have gained or theoretical knowledge if you want to verify that with an experiment, then this session is for you. So let me share my screen and I will talk about that what we are going to do today. Okay. So yeah. So this is my board, and let me keep it slightly here. And yeah, so let's do this. So we are going to talk about what is your, let's say, what is a rule-based system. Versus your AI/ML-based system. So let's talk about, first of all, what is rule-based system. So if we see my previous example that I have given, we have done certain experiments, right? So that experiment in the previous video. So actually for this video, let me tell you that that is going to be a prerequisite. So prerequisites will be like for my previous video. You should all definitely watch it. It's a worth watch. What's to watch? Actually, it is about 57 minutes of video, but it's a practical video, so you will definitely enjoy it. Okay, so I will put the link in my description, and I will also be utilizing the previous code that I've written to showcase this example and to show this difference practically. Okay, so what we can do is, this is going to be so that's a prerequisite, right? So in that example that I've taken, what I did is that I was taking a data, that is data stream from my phone, and it's nothing but it was a it's a sensors data, right? All the sensors, especially the IMU sensor, which is nothing but inertial measurement unit sensors. And I was streaming this data through an app, which I will be mentioning in the description box also, and the link will be also be available. And with this data that I was gaining from here, and I was passing through my, you can say, let's call this as a black box as of now, and this box was generating a control signals, or you can say signals to control any, let's say, game. I was controlling a game. You can control anything you want. So this I was doing. So control signal was getting generated. But if you carefully observe that, so there were few if else conditions for this. I will going to show you this practically also, and so that you can see the code there and you will be able to identify it. So there were certain if and else conditions, and both based on that conditions, I was generating some like signals. So what is a rule-based system now? So this is one of the good example of a rule-based system. So what is this? I am writing certain rules. Based on that rules, I was generating certain signals. So this is called as rule-based system. So it's a good for a system like the way that the example that I've shown in the previous section, or in the previous session, that example was actually, it's a good example of a rule-based system. And it can work well also. It was performing really well. There was no issue. But let's say if you have a, so in that you have a very complex system, or let's say if you have a if you have a very complex example where you need to write rules, which is going to, it may become lengthy as well. So we have written, in that case there were 5 rules, and those rules were for generating a halt signal, then forward signal, then there was a retreat, left signal, and right signal. So these are the signals that we were generating in that case. And based on that, based on these if-else condition, I was generating this control signal based on certain if-else conditions. So I have written 5 rules in that one. So what if I don't have to write these rules? How I can make my system intelligent so that I don't have to write these rules and it will automatically predict the outcome based on the model it is trained. So for that, we will be doing this. We will be creating an AI or ML based system. So let me talk about what is that. So what we will be doing is that we will be recording just in this way, the way we have done the previous session. So we will be taking again a raw data, that is raw data which is coming from your phone or IMU sensors of your phone, and this will be passed into a module which will be recording your data. Okay, this data will be recorded as a CSV file. Okay, we will be recording the CSV file, and then after that what we will do is we will use this data to train a model. So there will be another module which will be taking this data and it will be training a model, and it will train and save a model, let's say. Okay, so this thing we are going to do in this module, and then after that we will be utilizing this trained model to predict the outcome. Okay, so here in this you can see we will be directly predicting without using any if else conditions. We are writing a manual rule. We will be using the model will be taking a data which is the same data. The way I have streamed this data, similarly we will be using the data streaming from our phone, live data, you can say data stream or a live data which we will be taking. And with the help of this one and the model that we have created from the past data, or you can say historical data that we have streamed, with the help of that, I will be predicting the outcome. And this outcome is nothing but it is going to generate our control signal, and we will be again operating our app. Okay, or let's say we will be playing a game for this example again, just to prove that, okay, we are able to generate certain control signals. So this is nothing but it's an AI based system. So this is going to be like rule-less, you can say, without any rule. So it will automatically, our model will be trained on the data, and what it will do is based on that, it will try to create the model, and it will save certain parameters. It will automatically learn all those weights, or you can say learn the parameters, and based on the parameters, it will generate the signals, or it will give the outcome that we need. So let's try to build this. And okay, so in today's session, what we will do is we will first of all record the data. Okay, this is going to be our first session. Then tomorrow, what we are going to do is in the next session, we are going to train the data on this, train the model on the particular data. And we will also analyze the data, that how means what is our data looks like and what is that. Then after that, we will be doing what we will be in this third session, we will be creating this model, and we will be utilizing this, or you will be consuming this model in our code, and then we will try to generate the control signal. So this is going to be a 3-part session. So let's try to do this, record the data first of all. Okay, so let me just go to my Chrome browser. So here you can see that this was the session I was talking about. So you need to go through this session in order to understand today's session also, because I have talked about various things in this one. I have talked about a lot of stuff like about how to generate and how to make a rule-based system. So, and the code for this is also given this here, and I have already opened this code here. So if you open this one in rx.py, so this is your receiver.py. So we will be utilizing this code, and we will be modifying this to some extent. So let me just copy this. Okay, let's say I will be copying this here in my VS Code. So let's create first of all a new file here, and let's call this file as let's say old rx or old receiver.py. This is your just to save the whatever outcome we have. Now let's create another file. This I will keep just for reference, and let's create this file as let's say we will be calling this as a record data. Okay, so this is going to be a record data module, which is going to record the data, which we will be streaming from our phone. Okay, so we will keep this record data here, and let me copy paste here this one, same here, and we will be modifying for our requirements. Okay, so what we can do is first of all, let's get rid of all these keyword part. So because we do not require this keyboard output, so we will get rid of all those things. We will keep this socket and all, and we can generate, instead of calling this control signal, what we can do is we will call this as a record, and we will not be utilizing this keyboard.release and press all the information. and we will do some minor changes here. So let's go here and we can add one more argument because we are going to create a data. So this data, let's call this default value as a data.csv, and let's call this argument as a CSV file or CSV, okay, icon CSV, and we need to parse this as well. So parse this argument, instead of calling this host, we will call this as a CSV. So we will be sending the CSV file here in the main. Okay, so in this one, what we will do is we will pass this CSV here. Okay, so now what we can do is let me first of all get rid of all this. So here what we can see that we are already like we have this information. So it seems like let's make it a function here, right? So let's remove this from here and let's call this as a let's call this module as a record data module. So we will make this as a rule based module. So we will call this as a rule based module, and it will be expecting gravity data. Gravity data it will be expecting, and let's define this here in this function here. So let's call this as a again rule based module, and it will be expecting signals. Okay, actually gravity data, gravity underscore data it is expecting, and that's all. So I did nothing here, just I have created one function here, which is nothing but a rule based module. And yeah, so I think that we have done here. So what we can do now is, yeah, so we are done with this one, and we have got this CSV file. So here what we have to do is, in order to create a CSV file, first of all, we need to initiate it as well. The reason for initiation is that we need to put all the header file here. So init your, let's say, init a CSV file, init the CSV file, and it is going to accept a CSV file underscore file argument. So we will be utilizing this one, and we will be writing our, like you can say with, we will be opening the CSV file with open, and let's call this CSV file. We will be appending the data here, and let's call the alias here. And then what we will be doing is we will be first of all writing this file. So for that we need some string here that we want to enter. So this string is going to be it's going to contain your gravity x, that is x-axis, gravity y, and also it will accept as one thing that is going to be a target value. Target is nothing but target. These are the heading of the column that we need. So this is going to be gx, gy, and the heading of that data that we need. That is the column. That is the, you can say, the signals that we are generating. That is halt, forward, backward, and these are the signals that we are generating. So we can also think that as a class as well. So we are going to generate those classes. So this is going to be our outcome. So this is nothing but this model that we are going to create is nothing but it is going to be a classification model. So so this way we can write the header first of all, and then after that what we can do is go for f write lines, right? F write lines, and then call for this string. Let's pass this string. One important thing that we need is here is we need to also put a new line here, a new line character at the end. So we will be writing that at the end. The reason is that so that whenever we will append the data, so it should go just below this line. Otherwise, if I do not mention them, so it will come in the same line, it will be of no use. So that's how we are in it. We have initialized our data, that is initialize our data.csv file. So we will call after this init CSV file, and we need to pass the value CSV here. So CSV file, we need to pass the same, that is data.csv that we have generated. So in this way, we have done the initialization. Now it is coming into the rule-based area here, and let's call this as a CSV also. Pass the CSV file here as well. We'll talk about why we need this. So we have created this rule base, and we have also passed the CSV file to this rule base as well. Okay. Rule base CSV. Now here you can see that we were actually generating these things, right? We are generating these signals. We do not need that. Actually, we need to record what is coming in. So we will be changing all this information here. So let me just first of all. And we can get rid of all this, like this one will be record underscore data underscore CSV. So we can call this or a record data model, just we are recording this data, and it is going to accept the signals as well. And let's go for a CSV file as well. So let's accept a CSV file here, and this CSV file, okay, so this CSV file, we are going to accept it here, and we are going to write it into a we need to open this file, that is with open, and we will be opening the CSV file. We need to pass an append because we will be doing an append operation, and we will be calling this alias, and then after we will be doing some operations here. Okay, so this is we need to call here record data. And one more thing is that here you can see that we are generating a control signal. So we, instead of generating control signals, we need to record this data. So let's replace all these control signals with this one. Okay, this is going to be, yeah. So all the control signals will be replaced by that. So this is CSV actually. So CSV file is equals to CSV, we can call. Okay, I think we need to again do this few changes here, or we can do what, this, just copy this one, keep on pasting. Here you can see an extra that is there. So this is again here, we need to replace all these things. So I think everything seems fine here. Now, what we need to do is, instead of passing, so we need to get rid of all this one. So what we can call here is, we need to get this gravity data. And since we are only recording X and Y axis, we are not recording Z axis. So that's why what we can do is, we can get rid of the last one. Now what we can do is, let's copy paste here everywhere. So we are going to pass all this information every time. Okay. So this is going to be the same in every case. So whatever data is going to become here, so it will going to be passed into the CSV file. And let's call this as a, instead of calling this a signal release, we will call this as a let's call this as a dependent variable. So this is going to be a dependent variable that we are expecting here. So let's copy paste again this one. Instead of signal release, we will be replacing it with dependent variable. Yes. Now what we can do is, so for the halt signal, what we can call this as a target column. So we are expecting a target column. Now here, instead of sending this one, that is key dot space, what we can do is, we can go for a value. Let's say, so we are specifying our classes between 0 to 4, since we are having a 5 number of classes. So what we can do is, we can copy paste this here, and we will be changing this to this. So right now it is 0. I will be changing that again. So let's me paste this here first of all. So this is done here, done again here, and yeah. So now what we can do is, yeah. So here you can see that hard signal will be having this gravity data and is expecting a target value. So 0 is there, and this one here I can call this for forward signal. Let's call this as 1. For retreat, we can call this as 2. We can okay, there is, I think something is missed, maybe. Just a moment, guys. There's something is missing. Okay, so I actually missed this one. Yeah. So here you can see 0 hot for halt signal. Forward signal will be replaced by 1. Okay, there is an extra P there. Then there will be 2, and then there is 3 for the left signal. For the 4th for the this right turn. Okay, so in this way, what we did, we have recorded the data, and we are sending the signals to our record data function, and we are also sending the CSV file where we want to write it. And here in the record data, we are opening the CSV file, and we are writing this into a file. So now for what we can do is, we need to call this a string is equals to, let's keep it as empty as of now. And now what we can do is, just like below, we can iterate over the signal for signal in signals that we are getting. But this time we need to, instead of signal release, what we have a dependent variable. Okay, dependent variable. So we need to iterate over the dependent variable. And what we can do is we will be appending this string, and this will be accepting this will expect that is whatever signal that you have. Okay, and there will be a comma, because we are creating what, we are creating a comma separated value. So what we'll do, it will first of all record a gx value, and then comma, and then gy value it will record. That's all. Then after that, what we need to do is we need to append again this string with the target value that we need. So the target value will be, again, let's call for an f string, and this will be again going to be a signals. That is, this is going to be signals, and there will be no comma at the end. Plus, here we can mention that we need a target column now. So, and then after that, a new line character at the end. So what we did here is we have, first of all, what we did is we have taken an empty string. We have appended gx here. Then we have appended whatever gy is coming, that is gravity in y direction. And we have also appended the target column at the end. After that, what we did is we are recalling for a new line character, so that whenever we will be appending the next data, it is going to be in the next line. Now what we can do, we can get rid of this press signals. Okay, so everything seems to be fine here for me now. I think we have created another argument, that is csv file, that is data.csv, and we have created a rule-based module, that is new module that we have created. We just did what, we have just removed from here all this like if else condition, and we have moved it to an if else block here, that is your rule-based module. And once we entered into the main section, first of all, we have initialized our CSV file, that is with the header tag that we need. And after initialization, we went to the, again, same thing, that is byte we have received. So this, for understanding this, you can always refer to my previous video. It is very, very in detail. And then after that, what we can do is gravity data, that is, we have already done with that. And we are passing gravity data and the CSV file name that we have created. That CSV file name is again passed to this rule-based model. We have created that, right? And now what we did is, in this one, we have got the gravity data. We are just printing it again. If you do not want to do it, then it's okay. And then we have created a signals. Okay, we have dependent variable signal and then target signal. We are recording all this information into this because this record data module, where we are recording it into a comma separated value format. And we are also passing the CSV file. So in that CSV file, everything will be appended at the end. So what we are doing is we are utilizing this rule-based system that we have built last time, and we are trying to use that as to record a data. And now on this one, we will train a multi-class classifier. Okay. So now let's try to run this. Okay. So if everything is fine, everything will, means you will get the results here. So let me keep it here, and I will open this one, that is this terminal. And let me keep this here, right? And I will open this, first of all, this is screencast. This is screencast is nothing but it is my app that I'm using. So if you see here, so this is the same IMU plus GPS sensor app. So it contains all the toggle values, all the toggle sensors, that is accelerometer, gyroscope, magnetic field. And we were utilizing this gravity data. So we will click check on that, and make sure you are also check the include user check sensor data in the stream. And go to the preferences. You need to specify that's which IP address you are using, or local address. So I will be utilizing this 0.6, and I have done this 555 port, that is already by default I'm utilizing, and it is also mentioned in my code. And I'm taking this frequency to fastest frequency. You can go choose any of the frequency you can, and then let's go for a like this one, UDP stream, and run in background. You can keep it, and then also you can go for a switch stream, that is you can on the switch. Now let's try to run this. Okay, so Python, first of all, let's try to run our Python code for the recording our data. So record underscore data, yes, everything is fine. Okay, there is something is missing. What we did is, okay, invalid syntax. So this kind of issue comes up because what I did here is I was using an inverted commas, and inside also I was using inverted commas. So the solution for this one, either you can go for here, you can go for a single inverted commas. Now if I try to run this, I think there is not going to be an issue. So let me try to run it again. So it says that we have started with this port and this host. Now I will click on the yes. Okay, this is switch stream. So if everything is fine, so it is going to be okay. So there is some issue actually. Float object is not subscriptable. So let me first of all get rid of all that information. That is the issue that is having is float value is not subscriptable. So it is coming from some issues there. So let me just verify that. Okay. Okay. So I think I have done few mistakes here. First of all, this gravity data should be inside this one. That is after this for loop and this if else condition. Otherwise, it will not work. It will throw an error that it's reference before this one, because sometimes what happens, expected length will be less than 17. So that it should be in this condition. And then we can, if I look into this one, so there was an error that is float is not subscriptable. So here you can see I'm using signal instead of signals, because signals is my actual string, that is dictionary that I'm getting. So that's why there was an error that we were getting. So I think now everything is fine. If I run the python.py, you can see that on the left hand side, the data.csv is created. So that is zero. That means your file is initialized. So now let me go back to my second screen. That is where I have opened the app here. So I will now go for a switch stream. So I will click on switch stream. So you can see that halt is getting printed, forward is getting printed. Go for backward, that is retreat data. And let's again hold for there. Go for the left turn so that you can print the left turn. Go for the right turn so that you can print the right turn. Keep it halt again and again go for the forward. Again go for the retreat. Go for the left hand side. Go for the right turn. And then I think we can stop this one. So now we have all the data that we have done. We are recorded. So let me just verify this. First of all, I will cancel this now. Let's go back again and let's look into the data.csv that we have created. Okay, again, so there is some issue here. We were not able to record the data. There, I think there is some issue. Let me just verify it. So we are done with, okay. So you can see here, what we did is we have opened the file and we forgot to write the data. So these are the kinds of mistake that happens while writing your code. So these are some minor bugs, okay? So that you can get rid of. So we can, again, what we can do is we can write the string that we have created. So we need to write it into the files. So I think, so you can see that we already have this gx and gy in the target. So this is how initialize. So what we can do is let's get rid of it. Okay. And we can just delete this data.csv. Let me remove this data.csv. So let me run this again and I will keep it again on the left hand side. So hopefully this time everything works fine. So let me just again click on the record data button. It will initialize my CSV file. Again, let me just run this. So we can hot condition forward. We can again go for a retreat with again hot left turn, and then we can go for the right turn. Again, let's keep it at a halt button. Again, go for the forward, go for the retreat, and go for the left turn. Again, halt, and then again right turn. So I think that is enough data just to verify that you are able to get the data or not. So let me now again cancel it. Hopefully this time everything is right now. I think that this should be fine. Okay, so you can see that the data is getting recorded here. So target is there. This is the header file. As the top is the header of the column. And you can see that this is the comma separated value that is we are getting recorded. Now, if you want to just verify quickly, just go back to this one. That is go for the Python console. Let's import pandas here quickly. Pandas as PD. And then let's go for the df is equals to pd.read underscore csv. And since we have created data.csv, so call for data.csv here, file, and then let's check for the sample here. Let's check for the 7 samples or 5, whatever you want. So you can see that we have got the samples here. So gx, gy, and target column that we need is getting recorded. Okay, so all the 4 values is there. So now today what we did is we have recorded the data. Tomorrow what we will do, we will create a model out of it, and as a as a practice, what you can do, you can create your own data in your home and just try to build a classifier. Let's see that what classifier you will come up with, and then if you are able to generate the control signal with that model also, that will be great. So tomorrow what we will do, we will be analyzing this data, we will be creating a model, and then after that what we will do, we will save that model, and we will also utilize that model in the next session. We will be utilizing that model to like give the prediction, and we will get rid of all this if else condition that we have just utilized for recording our data. So in that way, we will be able to create an intelligent system. So stay tuned and just look into this. I hope you have enjoyed today's session because we will be practically seeing these things. Okay, so what we generally do is we either read an iris data set or something like that, and then based on that we do some learning. So it is actually fun when you are able to create a data of your own, a real-time data that we are generating, and we are saving the data. And if you're able to build a model, you can build a classifier on that. I think that is going to be a very real-time experience. So stay tuned, guys, and see you soon. And one more thing that I want to tell you that we are going to launch a deep learning batch again in on 17th of April from this Saturday onwards. So the seats are still there. So I hope you can look into the syllabus, and if you really like it, then do join it. Okay, I can assure you that you will be benefited from that. Okay. So that's all for today. I think let me just stop share and bye-bye. See you soon.